Welcome to the Open Loop podcast. It's a podcast exploring the people, companies, and ideas shaping the future of neurotechnology. I'm Chay, the founder of Carter Sciences, Recce Neuro, and the Neurotech newsletter. In each episode, I sit down with founders, operators, researchers, investors, and leaders building the edge of neuroscience, neurotechnology, and healthcare. We'll have honest conversations about people's journeys into the neurotech industry, what they're currently building, how it's going, the realities, the good, the bad, and the ugly, and what the future holds for the neurotech industry in general. Welcome to the latest episode of the podcast. I'm joined today by Ildar and Youssef from PiEEG, international meetup today from, I believe, Scotland, Canada, and Mexico, and myself. Great to have you guys with me today. I would love you guys to introduce yourselves to the audience, a bit about yourself, your backgrounds, and what you're currently working on. Over to you guys.
Thank you so much for your introduction, short. I'm Ildar, founder of PiEEG, also a scientist and engineer in the neuroscience hardware area and AI, of course. Also, I have Udemy courses for teaching and books about EEG, biodata, not just only EEG, also EMG and other types of biodata. So I work much more for the last year with hardware, but also responsible for software and another stuff in PiEEG.
Over to you, Youssef.
My name is Youssef. I'm the co-founder of PiEEG. Basically, I'm an engineer, a software architect, an autodidact. Over the last 2-3 decades, I've worked my way across an entire technical and different pipelines and industries, from embedded systems to web to telecommunication to AI orchestrations, AI agents, design. So my main focus was always user and developer experience, and I'm bringing this to BCI.
Fantastic. Thank you very much for that. I mean, I think it sounds like you both have quite diverse technical backgrounds. I know that obviously the BCI space, well, EEG technology has been around for a very, very long time, but the BCI space probably less so in its current form anyway. Certainly with the modern sort of software advancements allowing us to make sense of a little bit more of the EEG world. I'd love to know about your background that brought you into BCI. When was the first time you kind of first thought this might be a career or a co-founding opportunity for you guys?
For me, at the start, it was for fun. BCI, I was looking at it as if someone is looking at a keyboard or a mouse. It's an interface. So what can I do with it as a software developer? So for starting with BCI, it was just like a hobby. So I created a few open sources to learn it in the same time. As I said earlier, as autodidact, I learned by doing and creating stuff. And reading papers too, but mostly by doing and creating. So my first real project in BCI was Phantom Loop. It's in GitHub, MIT, open source. It's a web decoder for brain signals, basically. You can write algorithms inside the browser, run them inside the browser, and see the results directly if they work or not inside the browser. This is possible because modern internet browser now use web GPU. If we can play with video games, we can surely stream 142 channels of brain signals into a browser. So once I've done this, it was really for fun. So I posted it on Reddit. It was some attractions, and I continue. So I created Phantom Music. I created a lot of open sources. I don't really remember them all in short period. And finally, I met Ildar, and we discussed possibilities about PiEEG. The hardware is amazing, but the software, there were a few scripts. It's like a lot of hardware in BCI. I've noticed there is not a lot of attention about DX or UX. It's mostly for scientists or researchers, and very, very difficult very hard to start working BCI right now. So discuss this. I remember one of our first conversation is that PiEEG have one of the major problem is dependencies. So if dependencies upgrades or system upgrade, there are always a broken system between user and software. So we decided to write a software from scratch for PiEEG, and the PiEEG Server was born. And it was for one board at the first and then it expanded to multiple boards. It can communicate serial. It can communicate Bluetooth. It's a one-line install. It's plug and play. We have a dashboard. It's a web dashboard, and it's streaming WebSockets over the local network. It's streaming also OSC for users using VR chat or something like that. So it's a tiny, tiny server that can run on a Raspberry Pi. I can and have a huge use surface of software. It's all MIT too, and open source, GitHub, and this is it about it.
That's fantastic. Thank you. Ildar, how about yourself? What was because you've worked on quite a few different things as well. You've got a few little projects live right now.
So it was so wonderful story from Youssef that I'm ready to continue listen. Yes, it's originally, it's started quite similar because yes, I had experience already in hardware, in machine learning, and I want to test myself, my algorithms and neuroscience area, and I started to figure out about which types of hardware I can use. I didn't want to spend a lot of money, just only to test it, but I was very surprised because I didn't find any low cost and enough open source, something that I really wanted to use. So it was a quite high price. So I spent a lot of time and couldn't. What wrong? Why it's how it's possible? So for this reason, I decided, okay, probably for me it will be much more best way. Just only create my device. It will be much more easy to integrate for my software because you know about algorithms, firmware, and first devices here were created. Unfortunately, I spent much more time than I expected originally, but you know, when you started already, it's quite complicated stop because you're making some progress step by step. Yes, it was first device was created. I called it Iron BCI, make some publication about it. It was quite complicated device to create it, because it was sandwich format, few boards, and after that already it's many years ago happened after COVID, probably, or during COVID. As you know, it's a chip shortage, and price for many integrated circuits significantly increased. So for this reason, I decided, yes, it looks like I have very good device hardware, but price also became much more higher. So for this reason, I decided, yeah, probably it's better do something much more simple and cheaper. So, and of course, I understood that Raspberry Pi probably is the best way because it's already single board computer. It's just only create shield. You don't need to care about power supply, about microcontroller, data transfer. So, and exactly it was how was created PiEEG, and it was created. Yeah, I can tell story. Probably it will be later. I can also share about how I moved forward from PiEEG. But originally, yes, so it was interest. But my way, if compared with Youssef, I moved from hardware much more than from software and application.
Yeah, I was saying it's really interesting to hear people's stories about how they get into the space, because there's this traditional idea of you come from like a neuroscience background with a biomedical engineering focus, and then you're focused on EEG research throughout your entire studies, and then you come out of it with an idea about how to solve an indication, for instance, a specific medical target. Whereas for yourself, both of you, it sounds like you were focused on like biohacking to some degree, understanding the technology, the hardware, the software, and going, okay, why can't I get good stuff on the market? Why is it so bloody expensive? Let's build it ourselves. The fact that the Reddit community in this space is really fascinating, because it's very much, I follow some of it as well. I always see people talking about, like, I'm selling this device, I'm looking to get this device upgrading. There's a few out there, right? There's like the open BCIs of the world. And I've seen you guys describe yourself as low cost BCIs online. I mean, talk me through a bit of that and what what sort of usages you're seeing from people, and how it's going so far. How's the launch been?
So from the moment when was created PiEEG, we have launched a craft supply, raised some money, so it's already become from home project to company, and extend already our interest for other boards like Arduino. So we created shield for Arduino, for Jetson Nano, for STM microelectronics, and also make the wearable devices. So, and now increase it. We're working much more about increase amount of channels, and make it much more friendly, much more easy for using, documentation, everything. And already, of course, much more looking for software, for application, to make not just only hardware for research, make it much more consumer device.
For me, it's all about abstraction. So Ildar is one of the best in his field, uh, but I need to abstract him because I cannot understand what it's all about. Electrodes and microcontrollers. I just need a signal. So we created a really solid abstraction layer in Python, and it's solidified. Or there is another layer of Rust for people who need more speed. But with just Python, near zero dependencies, you can read data from almost all the PiEEG boards. It's really stable. You can record it. We have CLI. We have a lot of developer tools at this layer. Once this abstraction layer is done, it basically sends in the biodata over WebSockets. WebSockets is the same technology that we use right now for chatting. It's real-time web. Anything we use in the web or a lot of things that when it's real time, it's WebSockets. So we just stream in WebSockets, no proprietary C++ or I don't know. It's open, so anyone in the local network can connect on it, like it's connecting on a router and consume it. And because biodata is not easy to consume, by talking about 250 hertz of data, they took 250 samples per second to 500 samples per second. If we give this to a JavaScript or a React developer, the page will just freeze and crash. So we created hooks. We have React hooks. We have an entire ecosystem. We have a web dashboard. The main reason is to show the data, to show the spectrograms and everything. But the other reason is to give the users example how we can consume a lot of quantities of data in the web without crashing anything. Everything is seamless, and this is where we are right now. We have a very solid base. We have a device that can communicate with actually every device in the world, WebSockets, OAC, and webhooks. For example, Philips Hue, I don't know, bulbs, or all these devices use webhooks, and you can use PiEEG Server to trigger a webhook depending how on your data. So once these abstractions layers are done, and this is done, we can do everything we want. Now we are working on VR, we are working on XR, we're exploring a lot of products and directions. And you talked about the community. We discuss a lot on our Discord about our ideas with our community. We have a lot of ideas coming from our community that we implement. So soon, in a few months, we'll have a hackathon in Ottawa. This will be our first hackathon, but many users on Discord complain that they cannot be at Ottawa. We are creating a hackathon platform when users can volunteer to share their biodata over internet, and other users can connect to this biodata and assign tasks to these users, like protocols, and users apply these tags, and hackers can have experimenters in real time without having a device, because accessibility is also about working without a device. Working with the device can sometimes be a nightmare, but we have simulations, we have mock server. Everyone can start working on BCI right now using PiEEG Server with zero knowledge or device. Just JavaScript and React.
I forgot to say, Youssef mentioned very shortly about VR, but actually it's probably the main our project for the last month, and we spent all our time because very soon we are launch on crowdfunding platform our new device that transfer your face, let's say, emotion to your avatar. You can connect mask to your, for example, MetaQuest, and already from this moment you'll have opportunity to transfer your emotional, blinking, smiling to your avatar. So we'll make announce probably very soon about the setup already.
That's amazing. Is that it in the background there?
Yeah, exactly.
Amazing.
Some electrodes.
It's like a slightly more complex VR headset. I love it. I mean, you mentioned a few times, obviously, about open source platform. Is the goal to keep it open source, or I know that you crowdfunded in the past previously? What's the plan for it to become like a scalable commercial device, or are you guys saying no? We're keeping this in our world.
To be honest, it's not all open source. Some hardware, they not on open source from us. Software, yes, and open source. About commercialization, yes, we are going. Also, it's our separate project. And also inside PiEEG, we have a few projects that's going forward. Yeah, and probably, it's because for now, why it's open source? Because almost all our project, it's for research market. It's not for consumer. So, and for researcher, of course, it's very important to have access for everything, to know what is going on. But now already, yes, we have a few, much more, let's say, consumer project, and probably some parts of this consumer project will be already not so open as open for science. Probably, Yusuf, I don't know, what do you think about it?
For software, I'm really targeting adoption and to become a standard if possible. If it's MIT, if it's open source, if it's superior, if there is a community, if there is developers behind this community, I don't. It's success. Success is guaranteed for me. So open source can be a good strategy for software, and this is what we are doing right now. After that, we don't know.
Yeah. Well, it's just an interesting market, though, isn't it? Because I think the signal processing, BCI, wearable EEG market, it's something that is, even in like the medical neurotech community, is something that is still like forming adoption. Obviously, EEG is used a lot in the clinical settings, hospital settings, and so forth. But wearable take-home devices, we're seeing more and more of it. Everyone is using it at the moment for more targeted neurostimulation, for instance, in real time, which is really fascinating. But I think there's also this consumer market which is growing very, very quickly. I think, although we spoke about some of this stuff last time, this wearable EEG, the different form factors, the patches.
Yeah.
A couple of companies are developing right now the in-ear EEG, the under the skin, over the skull type, pseudo BCI medical devices. There's a lot happening in that space. I mean, is that the audience that you're kind of targeting, the direct to consumer, or are you looking at trying to get this to into a more medical setting at some point in the future?
Yeah. It's the most of what you mentioned. We're already moving in this direction. So we have in ear BCI. We are creating already hardware to move as medical to receive all certification. So it will be a long way. Of course, it's not something just on a create and receive, but we're already going in this direction. And yes, and different types of form factor, and also nerve stimulation as well.
Right. Excellent. How about yourself, Youssef? Is that like an area that you're like the medical device side of things, for instance, and like the stimulation side? Is that something that's of interest to yourself and you're working on? Obviously, it's quite unique from a software perspective.
For me personally, anything that is closed loop is really, really excited. So I can work at anything that where there is a feedback, the feedback is consumed, that there is another action, and this is fascinating. So yes, I'm looking forward to it, and hopefully it is gonna stay open source, the software side of it. Because another thing about open source is transparency. A lot of softwares we don't know anything about what algorithm behind they use behind. We don't know anything about the code is closed. We just have the final stream of signals. Open source guarantee the transparency, so researchers, users can really check the code and decide for themselves. Perhaps I talk about other things. Sorry.
No, all good.
I've gone elsewhere.
No, one of the things I wanted to ask you guys about is there's this big debate at the moment around neuroethics and brain data and foundational models and so forth. As obviously like there's a lot of crossover, I think, between AI software development companies and neurotech companies right now with the accumulation of brain data and foundational models. I mean, what are your thoughts on that? Is that something that you guys are looking at as well and focusing on?
Of course, we thought about it because we are a company. It's an end-to-end company. We are a hardware and software company in the same. We can do a lot of stuff, but it's not in a roadmap. It's not discussed yet. It's not just there is data. What can we do about it? Let's put this aside and think about it later.
That makes sense. I mean, what are your incorporations of LLMs into EEG at the moment with your current software and hardware components?
For software, at this moment you can bring your own AIs, meaning you can log into a PiEEG server, put in your API key, choose whatever provider, including local providers. So if you have a local LLM like I don't know Olama or many others, you can plug into them and ask questions about your data.
I love that. That's fascinating.
There is snapshots of data. Each time you type a message, it's sent with the context of a snapshot of the last X minutes or X seconds of data. So the LLM have a general idea of what's going on, and we just walk you through. And this is right. This is available and it's public. MIT.
Amazing. And what about your in-ear EEG stuff, Ildar, that you've been working on with athletes? Is that we incorporating the same type of software? Tell me more about that business as a whole.
Yeah, it's quite separate story, but we are both involved. So yes, it's in-ear brain computer interface integrated inside headphones. So idea how it was born, yes, originally, yes, as I said, PiEEG is much more for research market, but I always wanted to make something real working for consumer market, not just only as usually for focus, concentration. It's a lot for different types of application. I want to make something that really people want, and it was born from my probably from a private story. So I really like running, and I many years dreamed about participating in marathon, but I never know. I always was afraid. Can I reach final line or not? How much actually I have energy? When this moment happened, when I can just only stuck. And in the second, it's always and as a sportsman, they have a problem sometimes with overtraining. You are going to make some sport, but didn't calculate in your head right, and when you return back, you just only fall down because it's happened overtraining, not so often, but it's quite sorry when it's happened. So for this reason, I also wanted to make something that can help me avoid it. Something, like in gasoline in car, but for your energy. And it's we have devices that can say, or methods that can say that you are tired, you don't have energy, stop it or something. But just to predict, looks like it's possible just only signals from brain. When you look in future. So for this reason I decided, wow, probably it's a great opportunity since I already have a company that produces brain computer interfaces, make it for consumers smaller, and created algorithms and start use it for athletes to have opportunity avoid overtraining. It's before make sport, you have opportunity to receive information about what better to do about your current energy stage during sport activity. It's something like alarm, threshold, stop to avoid any overtraining, and after training, after sport activity, you can receive some recommendation about recovery. And in this case, yes, the brand, it's very cool, great indicator, and yes, it's this market. And no one company didn't provide yet a solution, especially for ear EEG for sports. So for this reason, we decided that it's very prospect direction and started moving.
I love that. I mean, so it's kind of like a research tool for yourself to start with, to understand what your brain, what your body was going through. Yeah, that's fascinating. So is that being actively used then in the market, or is that something that is? I mean, how do you launch something like that with like an athletic component? Are you giving it to sort of friends and family to start off with? Are you approaching sports teams, or what's the focus there? Because you're accumulating some really interesting data too.
Yeah. So, but it's we still on the begin, let's say, with these types of project. We created different types of prototypes, but it's quite complicated. Make some real device that will works outside from the lab. It's some limitation. It's the main limitation. It's just only mechanical because you should have very good connection between electrodes and air. So we spent a lot of times just only to find solution which one is better. Another one, of course, you need to collect data sets. So for now, yes, we have some prototypes, published papers, made just only 1 or 2 months ago presentation on science conference, and have connection with different types of organization, but we didn't start yet test it because we are still we're already very close to MVP, but MVP was not finalized. We have prototypes that can use just only, let's say, during our control with some preparation. It's take time, but we are going to MVP right now. But I would like to say, yes, it's a lot of interest, and we already have a very nice connection from sport area.
Excellent. Yeah, there's a few interesting things happening at the moment in that space. I think the wearable EEG market, there's lots, like I said before, with different form factors. But it's interesting having a separate BCI and recording tool for research purposes. Youssef, how different is it interpreting that data from athletic performance and understanding it and decoding it in real time versus, say, for instance, just a regular usage for research purposes?
I think it's the same platform, the same data, the same stream, the same frame per second. So the algorithms for interpretations will be different, of course, but the processing is basically the same. But perhaps the difference is the PiEEG server can run on Windows, Raspberry Pi, and Mac OS, and for Mirans, or this must be on a mobile phone experience companion. Other than that, for me, it's like the same thing.
Yeah, it's more like when you're using it as opposed to what you're actually using it for. The
Exactly.
sort of timing of it. Yeah, that makes sense. And what do you guys see the future of the low-cost BCI space then? Obviously, there's not that many products out there at the moment. There's like I mentioned it before, there's lots of these direct-to-consumer devices you can buy online. There's some BCI companies out there. I think the understanding of what the EEG world actually looks like is kind of bare to the general public right now. One of the things I always say is that the biggest hard part about neurotech is explaining to regular people the importance of, or how to analyze brain data, or the importance of it. I mean, what do you guys think the future looks like for this space, and how do you think you can tackle that interpretation of brain data for the general public?
Yeah, let me start from hardware point of view. Probably, it's neuroscience and brain-computer interface. It's not something new. My vision is not so bright, let's say, because we still don't have any devices that you can just only open Amazon and buy real brain-computer interface, let's say. Of course, you can find something similar, but something that's really allow you make something like motor imagery, read some much more useful signals from your brain. It's still impossible to find. So it's it's a lot of limitation. Yeah, as I said, it's since usually it's a brain-computer interface, and when we see some achievements, it's a lot of achievement in this area. Actually, if you're looking some science paper, you can find evidence for different types of situation, but still nothing for consumer market. Not nothing, but not something really big. It's because it's as I said before, it's need a good connection, but you can do it, of course. Another one, you need collect huge data sets, but huge data sets were collected, and we already have, thanks to AI, very good models with LLM, or not only. But anyway, it's not solved our problems. Probably, from my point of view, we need to create what I would like to say finally. Just don't use already standard brain-computer interface, because when we use non-invasive, it's just only 8, 16, 32 EEG channels according to your head. And it still continue already decades, probably already its way. It's something that's again what we are doing. We will very soon start test a new board. It will be something like coins, but around these coins will be 16 electrodes. It looks like invasive, but not invasive. So probably it's this direction provides something new opportunity for us. But from standard implementation, I don't see any big prospect, and just only an EEG area. Probably in-ear EEG can help us, but let's see. And we are also doing everything what we can here.
It's a lot of opportunity to grow them.
Yeah.
Yeah, absolutely.
And just to add to Ildar about software, for PiEEG, we are creating a platform. So we are trying to lower the barrier, the entry barrier, so other developers can perhaps come in and have better ideas, or other creators, and we can develop BCI by having a lot of developers and big community working on BCI, and we can do this with programs like PiEEG Server, because we can work with simulation, etc., and it's really easy. So let's make it easy. Perhaps it will succeed. For now, it's difficult. About AI agents, we are thinking about education too. So we're talking about right now creating like an AI agent who can serve like an educational agent for BCI community, but all answer questions, help users, and it's sort of academy powered by agents, and but also to use it directly inside PiEEG servers, so user can interact with their signal definitely, and the agent can change parameters alone. Agent can read the local data sets. Agent can have better questions. And we are thinking of it like a co-pilot or something for PiEEG, and this will be our next project, software project, I believe.
That's fantastic. I mean, that's really interesting. Would that be sort of in order to create greater access for people maybe less technically savvy than some other people? Yeah.
Exactly. We want people ask question, interpret. Sorry for my accent. Interpret my data, or do you see noise? Why there is noise? How do I have to think differently? Can you write? So this is for beginners, for perhaps for students, for engineer. Can you please write me a new algorithm? Can you please write me a Jupyter notebook about X, Y, X, about my data? So it's gonna be an agent that can interact with local file systems, and not only with PiEEG server, but also with users files and our documentation, something complete.
I love that. That's great.
Copilot.
Yeah, that's it. Yeah, keep it simple. No, that's great. I think that the general, like I mentioned before, right, it's about the translating information to the general public is the key, but also accessibility to and people understanding why it's important and what we can learn. I think we're such early days still within the industry of people starting to talk about brain data and understanding what certainly even brain states and brain waves mean. I spoke to somebody recently who's working on the brain entrainment space through like binaural beats and different music in that space. And it's just fascinating to think how quite well known to some degree. It's quite a relatively regular conversation amongst some people, but we are also very much in a bubble of our our BCI and neurotech interest and understanding neuroscience to some degree. But even then, it's majority of people don't. So it's fascinating to be able to say, hey, look, we can create agents which will actually do this work for you, cut out all the hard work, all the guesswork as well. And it's not just for people who are down the rabbit hole of passion and interest. It's actually something a little bit more available, I suppose is probably the best word. That's good. Well, thank you very much, guys. I really, really appreciate your time. Really fascinating to learn about this. Where can people access this information, access any hardware, software? Like what's available right now for people?
There's a website, PiEEG.com. The hardware is accessible. Users can buy it right now. Software is open source, PiEEG server, and it's on GitHub, MIT licensed. And there is a community in Discord. It's open. Everybody can join. Everything exists.
Actually, everything's there.
Yeah.
Yeah. In this case, yeah, we are open. We are open as we can.
Fantastic, guys. Everyone should go check that out. Really, really appreciate you guys taking the time today. It's fascinating to see this other side of the market where so many people talk about BCIs and the like big 4 or 5 companies and the hundreds of $1 million flowing into it, and to see you guys building something which is entire purpose is to make it more accessible to the general public and for people to understand, more freely what's going on in their heads. So thank you very much, guys. Really great work.
Yeah, thank you so much. Yeah, it was amazing conversation.
Cheers. Thank you. This podcast is brought to you by Carter Sciences, the headhunting practice that covers not only headhunting, but also fractional talent work for startups who need help, but don't want to spend those big recruitment fees, wanting to work on a more hourly basis with companies, and also career coaching for neurotech professionals. Goal is to provide cost-effective solutions across all neurotech hiring needs.